Welcome to ShubhCode. This is episode 1 of the LWC interview questions series. Today's topic, LWC component lifecycle. Questions only seniors answer correctly. The lifecycle hooks that interviewers use to separate junior from senior LWC developers. These are real questions from real Salesforce interviews. Let's get straight into it. Here is what we're covering today. What is the LWC component lifecycle? Then, connected callback versus rendered callback. When does each fire? Then, why should you never put API calls in rendered callback? Then, disconnected callback. What does it do and when do you need it? Then, what is the correct order of lifecycle hooks in a parent-child tree? Pay close attention to the last one. It's a follow-up question that even experienced developers get wrong. The lifecycle question is in every LWC interview, and the way you answer it tells the interviewer immediately whether you've used LWC in real projects or just read the documentation. Here's the complete answer. LWC components go through a defined set of phases from creation to destruction. The framework manages these phases automatically. As a developer, you hook into them using lifecycle callback methods. There are 4 main hooks you need to know: constructor, connected callback, rendered callback, and disconnected callback. Understanding exactly when each fires, and more importantly, what you should and should not do in each, is what separates a junior developer who uses LWC from a senior developer who understands it. This is the trap question and most candidates walk right into it. Here's what happens if you put a wire call or an imperative apex call inside rendered callback. The API call fires. The response comes back with new data. The data change causes the component to re-render. The re-render triggers rendered callback again. The API call fires again. New data. Re-render rendered callback. API call. Infinite loop. You'll see this as a component that keeps flickering. API calls firing hundreds of times. And eventually either the browser tab crashes or Salesforce rate limits your Apex calls. The correct approach. Use connected callback for any API calls you want to run once when the component loads. Use rendered callback only for operations on the DOM that depend on the rendered HTML, like initializing a third-party JavaScript library that needs actual DOM elements to attach to. This is the advanced lifecycle question that trips up even experienced developers. When you have a parent component that contains child components, what order do the lifecycle hooks fire in? Here's the exact answer. The parent's constructor fires first, then the parent's connected callback fires. Then the children are rendered. Each child's constructor fires. Then each child's connected callback. Then, and this is the critical part, the children's rendered callback fires first, working back up the tree. Then the parent's rendered callback fires last. In other words, parent constructs, parent connects, children construct and connect top-down, then renders complete bottom-up. This matters enormously when you're trying to access a child component's public property in the parent. That data isn't available until after all renders complete. Most candidates know that disconnected callback fires when a component is removed from the DOM, but interviewers want to know when you actually need to use it. The answer is, anytime your component sets something up that persists beyond the component itself. 3 main cases. First, message channel subscriptions. If you subscribe to a Lightning message channel in connected callback, you must unsubscribe in disconnected callback. If you don't, the subscription keeps listening even after the component is gone, causing memory leaks and potential errors when the handler fires on a destroyed component. Second, platform event subscriptions via EmpAPI. Same issue. Unsubscribe when done. Third, any JavaScript intervals or timeouts you've set with setInterval or setTimeout. If the component is destroyed while the interval is still running, the callback can fire on a non-existent DOM element. Let's wrap up. Here are the answers that will make you stand out in your next LWC interview. 4 lifecycle hooks: constructor, connected callback, rendered callback, disconnected callback. Never put API calls in rendered callback. Use connected callback instead. Use a hasRendered guard flag in rendered callback to prevent rerun on re. Renders parent lifecycle top-down. Renders complete bottom-up. Always unsubscribe from message channels and clear intervals in disconnected callback. Practice these patterns in a Scratch org so they come naturally in an interview. Like and subscribe for a new LWC question every single day. Next up, Episode 2, LWC Data Binding, Tracked versus Reactive, API Properties, and the Parent-Child Communication Questions. See you tomorrow.